Yes, welcome everybody once again for all those who joined a little bit later. So we are here with Cyber Life, Automate Your Cyber Defense with Microsoft Sentinel. My name is Jeroen van der Leur. A quick introduction about myself. I'm working at Proximus Next as the Microsoft Security Center of Excellence lead. So together with a team of engineers with a lot of great colleagues, we are working on Microsoft projects related to cybersecurity. It is a combination between Microsoft 365 and Azure environments, and also helping out with our great team related to Manage, Detect, and Respond, where we are also working, for example, with Microsoft Sentinel theme. So with that being said, I think for some of you who already saw maybe my profile, I'm also a SANS instructor. So I'm already like working 4 years for SANS as an author and an instructor. And together with Jason Ostrom, we wrote our own course related to security automation. And actually this year, we even updated the course content related to automation and how you can practically now use Gen AI within your automation strategies. Now let's move a little bit further and let's discuss the content of this presentation. So first of all, I divided it a little bit in three parts, where the first part is, okay, why does security automation matters? So why are we working with security automation? What are some of the key things and why is it a requirement these days for a modern security operations center? Then as well, we're going to see a little bit like, okay, how does it map then on the Microsoft technology stack? So what can we use for a specific use case related to automation, and how can we, for example, apply preventive controls, or how can we do detect and rapid response, which could be a great added value for your own security posture. And then last but not least, and I think that's also going to be the larger part of this presentation, is really like, okay, let's demonstrate this. Let's work with Sentinel. Let's work with logic apps, for example. How can we stop, for example, certain bad actors based on detection and rapid response? Do not worry, it's a technical session, but we will remain also in a high level perspective. And I think it's a great added value for everybody that is invested in cybersecurity, meaning there on how you can actually apply security automation. So from that perspective as well, I really want to make sure we are going to use some dedicated and some very specific technologies here. But of course, the overall process there as well, it's something that you can take out of the technology stack and actually also work with other tool sets that are able to, for example, automate your infrastructure and your cybersecurity activities. So let's start with the beginning. Why security automation matters and what about security automation? Now, maybe just also from that perspective, cybersecurity, it's a passion. That's definitely true for me as well. So cybersecurity is one of my main passions, but also sports. So I'm a very enthusiastic related to sitting the entire day behind computers, but also I'm very enthusiastic when I can leave my computer and go, for example, towards the gym and have some exercise over there. Now, think about automation. That's one of the key things I wanted to mention here. Why? Because, for example, if I think about automation, well, what should I automate first? If you're going to try, for example, to automate your sports activities, well, you can do that, as you can see now on the screen. So this is actually automated. I can do automated 10 kilometers per day or my 10,000 miles per day even. But of course, the overall result of this approach is not really beneficial for your own objective, like, for example, to get those steps done. Because you see here as well, there's no real activity. It's just strolling on the treadmill. And I see a lot when I'm talking to customers, when I work with customers, I see a lot of automations. being used that actually have the same principle. Now, they are helping, for example, a security operations center by creating tickets automatically, but also there, that's only a very, very small, a very, very dedicated use case. And from an objective perspective, probably also something that will, yeah, get the least value towards your security engineers and your security analysts. So what about security automation and why is it needed? Well, first of all, I think we all understand that, and I don't need to go in detail here with facts and figures. But there's a growing threat landscape. So you have the nation states, we see attacks all over the place. We see also, for example, ransomware. We see a heavily increase already for years related to ransomware, especially for unmanaged devices these days, or where there is low visibility. And I think, within Belgium, if you are from Belgium itself, then you will probably also saw this, you also saw this in the news the last weekend, that there are some issues related to a ransomware attack on a very important and critical sector within Belgium. Also the speed, the scale, sophistication. So in certain cases, the speed with how attackers are actually doing reconnaissance and are actually pinpointing certain infrastructure or certain components within your infrastructure, we see that that is also very, very rapidly growing. And now these days, especially with AI, to be honest, I'm not an OT expert, but thanks to my dear friend Copilot or ChatGTP, I can actually upload a PCAP file for an OT environment, so know what's going over the network and try to make it a little bit more readable and try to actually work with those kind of tools also from an attack perspective to see, okay, what can go wrong here. So we see that attackers are also leveraging these kind of things, and yeah, it's becoming more and more, it's going to become more and more complex, and it's going to become also much easier to target certain infrastructure. So that's also why, from a defensive side, we need to have attention related to that. So attacks happen in minutes instead of days. I think that we definitely see attackers are taking advantage of security silos. So we also see that there's a huge amount of technology involved. A lot of technology is being handled by their own experts or by their own competence centers, and which are working in a security silo as such, or the cybersecurity team as such is a silo. So from that manner, we also see that certain attacks are still not visible, are actually detected way too late. And it's just becoming more and more, especially now also with multi-cloud environments, it's becoming more and more relevant to have like a holistic view on what is going on within my environment. And then I think last but not least, we have a lot of, how do you say it, open vacancies on our website related to cybersecurity. It's difficult to find talent at this moment. So a lot of talent is there, a lot of expertise is out there, but to be honest, there's not enough talent, there's not enough resources available at this moment to do everything manually. So I think automation, and especially if you combine it with Gen AI, can definitely be a great help from that perspective. Just as a reference, this is the article. You probably also saw it in the international news, but European airports, they are under attack at the moment, or they had an attack starting on Friday this weekend. So it was actually a supply chain attack. So it was related to the ticketing print service. And they were able to actually install ransomware on certain systems. The investigation is still ongoing, so the full details are not yet fully available. But from that perspective, you see that even an international or several European airports are even target and are even, they are vulnerable to these kind of attacks. So a ransomware, what is the key to try to prevent the ransomware as soon as possible? It's actually to detect it as soon as possible, and then also to have rapid response in place to minimize the impact on your total environment. So based on that, we are also going to see that in the demonstration on how we can leverage detection and rapid response and how we can make it a little bit more efficient and effective to respond on certain incidents. Now, what is also an important fact, defenders, we typically, we need a new approach. We are always looking and we are always striving to have that new and innovative approach. Also here on the internal side, we are thinking daily about internal innovation. Okay, how can we, for example, create more visibility? What kind of tools can we integrate? How can we automate certain processes just to get the amount of work done with the resources we have available? If you have common tasks that are executed in a repeated order, well, probably it's a good idea, for example, to have a look, okay, is there a certain way to automate these kind of tasks? And again, an automation typically has a trigger and it has several actions in place where, in most cases, there also is still a human in the loop to actually validate, okay, what action is proposed here and what action are we going to take. So one of the things where we as a defender are typically struggling with, well, to be honest, complex tool sets. Remember the days when security was all about firewalls, or even before that, access lists that you were configuring on your main router, on your internet gateway. Now, these days are over. Not that you don't need to do it anymore, but it's just nowadays with all the cloud environments, with the SaaS solutions, it's becoming a more broader landscape and also a more complex tool set. You have API gateways, you have reverse proxies, you have forward proxies, all these kind of things have their own feature set, and they all need to be aligned next to each other to have that full visibility, which from a minimal perspective, if you need to have all those portals next to each other, well, it becomes quite complex. Likewise with posture drift, because it's such a large environment, I think there as well, a lot is changing continuously. Examples that you have like Spotify and Facebook, they are continuously developing and continuously building new features. They are releasing, for example, every day, like 2 updates on an application. So from a cybersecurity perspective, that's difficult to manage if you really need to do that in a manual perspective. And also attacks are becoming more and more sophisticated. Now, I don't say that it are only sophisticated attacks that are currently working, because attackers also know, for example, ransomware, that it's still a valid business model and they are still earning a lot of money with, for example, those standardized ransomware attacks. Now, from an internal perspective there as well, so disconnected processes. So again, those silos, we see that quite often, like there's no real link with IT operations or with the cloud experts. There's no real security advisor within, for example, certain teams. So those kind of things are still there. Same for bring your own devices, other cloud environments that are being used. So there as well, we see that the disconnected processes are a challenge these days. Shortage of talent and expertise, I already mentioned that, and inefficient collaboration, like for example, engineer A does it via tooling A, B, and C, while engineer B does it via tooling C, D, and E. So there's no way of standardizing that one, unless you are thinking about, okay, how can we, for example, create already a manual playbook so that they are following the same processes. So with that being said, we need a new approach to tackle these challenges, and automation can definitely help out. Is it the silver bullet? No, it's not the silver bullet that you just implement and it works. It's really like a journey that is taking you from, for example, a smaller thing that is heavy related to workload, to manual workload, but that is very repeatable in a short term. So start with those kind of things and then see how you can further improve that environment. Also, the demonstration itself, it's based on an actual use case that we have implemented in production at a certain customer. So from that perspective, we started with like something very basic, and then we actually developed on top of that. Detection and response equals prevention. So you probably already heard that. So prevent, of course, prevention is key. So if you can prevent certain things, definitely that's ideal. Now I have to be honest here. I'm a technical guy. I'm not a salesperson, and I don't believe in magical boxes. So I do believe in best of breed products, and I do believe in product capabilities that they are able to definitely prevent certain things. But I also believe that, yeah, those products need good people behind it, and that they actually also need to collaborate together, and that you cannot have like one magic box overall that is going to solve all your cybersecurity nightmares there. So from that perspective, prevention is definitely key. What you can prevent, that's something you definitely need to implement. But as you will see in our demonstration as well, there are certain capabilities that, for example, with Azure Web Application Firewalling, that are not able by default to detect certain patterns. And so from that perspective, it's great to have then our automation engineers think about those things and see, okay, how can we also prevent certain attacks rapidly in the detect and response scenario. And then, of course, improve, very important step, especially if you're working with detection and with automations, that you have feedback loops, that you collaborate with IT operations, for example, that you collaborate with management as well, to have like input, to have those feedback loops, to actually further fine-tune your improvements. And maybe you are able to migrate your detect and respond capabilities towards a preventive control. So with that being said, I think that's like a little bit of cycle we all know. I think let's have a look now at the Microsoft technology stack and put those products on that cycle. The Microsoft technology stack that I'm now going to explain is actually the stack that we are using in our demo. And within our demonstration, again, based on an actual use case. So it is in production running at the moment, but it's in my demonstration tenant. So to not disclose any other information there. But the use case we had is we need to protect a web application. We need to respond to threats, and we need to actually have automation and intelligence in place so we can respond rapidly and with a very high likelihood that a detection is actually something malicious that is going on. So from a prevent perspective on Azure, what do you have? Well, on Azure, from a prevent perspective, of course, you have access management, which is done by Microsoft Entra ID. We're not going to do a deep dive in Entra ID. We can do that in another session, but because to be honest, there are so many features for the Entra ID. But if you have never worked with Azure, what you have to keep in mind, Microsoft Entra ID is a little bit like the cloud solution, the main directory for your users, your devices. It's really like your identity service provider there. Second component that we can use for a web application is Azure Front Door. Now, Azure Front Door, it's like a reverse proxy. So what is it going to do? As already in the name, it's your front door. So there, everybody needs to come in, and you're not, or I hope you're not going to let them in via the back door. Or attackers are going to try and implement a backdoor, but with Azure Front Door, you want to have like a single point where all your web traffic is coming in, where you actually have a single point of control and where you can start, for example, your prevention capabilities. With Azure Front Door, you can even put a security policy on top of that, which is then like within the Azure Web Application Firewall. You will see that again in the demo. It's an Azure Web Application Firewall policy that we put in front of our Azure Front Door. Meaning there as well, it's like having multiple locks that you actually lock your front door and that you try to prevent, like, for example, bad actors. So an Azure Web Application Firewall, you can compare it with installing like a Ring doorbell with a camera, so you can see, okay, is that somebody I know or not? Those kind of things are actually comparable within the real world. And then you also have Microsoft Defender for Cloud Apps. If you are hosting your web application in Azure, then you have Defender for Cloud Apps. And if your web application is an app service, which is in our demo the case, then you can use, for example, Microsoft Defender for Cloud Apps. So these are some of the preventive controls and technologies we can use related to protecting our web application from bad actors. From a detection perspective, what can we do there? Well, because we have front door for that web application, and we also have our web application firewall policy, well, we can use those web traffic logs and we can use those web application firewall logs to see, okay, what are some of the suspicious activities? And that's actually what we are going to do. We are also going to onboard those logs into a centralized monitoring solution. In our case, it was also the topic of the presentation. It is Sentinel. So you see a little bit of schematic flow there. You have the Azure front door. They have like diagnostic settings where all the logs are. Then they are going to forward it towards a log analytic workspace, which is a structured table where your data is put in. And then you have your detection logic in Sentinel that's going to see if there are any anomalies. So when prevention fails, detection capabilities are required for suspicious activities. Again, the reasoning behind this, why I'm stating it here, is for prevention with the Azure WAF. So an Azure Web Application Firewall is signature-based. I can show it to you in the demo. So you will have a lot of rules related to signatures, but related to anomalies. It tries to do some anomaly detection, but in certain scenarios, it's just not that easy to do. And you probably want to have some additional capabilities there as well. So one of the things where Azure Web Application Firewall, so it's going to block known bad requests, but it doesn't know what is actually a good request for the backend web application because it never learned that application. If you compare it with, for example, larger web application firewalls like F5, there typically you have an application profile, which is then very fine-tuned. Now there as well, if you don't have like a full development process where your security and engineers also adapt the web application firewall policy on top of your application, well, there will always be certain items that attackers are going to try and execute and that you are not able to prevent. So what can we then also do from a response perspective? Well, once we detected it, well, then it generates, of course, an incident or a trigger, and that invokes our automation. So here again, you see the flow. We have our logs, we have our detection logic within Sentinel, and within Sentinel, if something occurs based on a detection logic that we have, we will trigger, like for example, a logic app, which is an automation. Now you can also do automation, and I know that, there are so many options, so many variables. Here we are just going to use the basic method related to logic apps, but you can also do it or integrate it with Azure Functions. You can also have automation with Copilot for security or agentic AI. All those things exist, but here we are just going to cover the basic principle of automation. And because it is a public web application, I also don't want to include too much Gen AI at this moment because I want to be really sure, because I'm going to fully automate this cycle, I want to be sure that a certain incident is actually a malicious incident, meaning that the traffic we detected includes malicious detections. So number of different attacks is high, time to automate. So there are so many attack scenarios. So I think there as well, it's time to automate there. And then of course the improve phase, I already mentioned it. So your detection rule set, initially it can be a very small detection rule. And ideally you want to have continuous improvement. And ideally you want to talk to your security analyst to see, okay, what am I missing? What kind of visibility are you lacking? And also, what is the false positive ratio? So a very good idea there as well is to work together with people that are daily operating those kind of things and to have that feedback. Same with your logic app. Tomorrow there could be not new features or you want to have additional capabilities. Well, have feedback loops, have like a continuous improvement process there as well in place. Review, improve, and maintain your automation playbook. It's not because you have one automation playbook and it works that it will work like within 1 year as well. So yeah, be aware that it takes some time and it also consumes some resources. So let's maybe go ahead and go to the demonstration. So stopping bad actors. Let's first explain a little bit the scenario. So high level, what is the scenario? Well, I already mentioned it in the previous slide. So we have an attacker. They will scan the website for potential flaws and confidential files. So we are now going to simulate it pretty easy just by doing manually requests that are then being blocked and where we see, okay, those kind of things are malicious. But it simulates how an attacker is using, for example, scanning tools, which are going to deliver or which are going to generate a huge number of valid requests, but also a huge number of malicious requests. Based on that ratio, you can then already determine like, okay, is this normal user behavior or not? So in this case, we took a ratio of 60% of the requests were bad, meaning that, yeah, the multitude of the traffic is actually being signature based, which typically indicates that you are working with a scanning tool. So the front door forwards those access logs towards our log analytic workspace, and then Sentinel monitors that one. It creates an incident, and within that incident, we are going to add that IP address towards watch list, and we are automatically going to upload it towards our Azure Web Application Firewall. So it's based on a custom detection rule. So pretty neat, no? I think so. It's going to be a customized attack in that sense, like, okay, we're going to execute it manually. It's a custom detection rule. And also we are automating like our flow related to that IP address. It has a lot of malicious requests. I don't want to see those requests on my backend, even if they are valid, because we know that that IP address is doing some weird things. So let's block it by default. So I will offload my backend as well. So this is how I typically do my demo, but let's now pray for the demo gods and let's see that everything is up and running. So this is my Azure environment. So it's a demonstration Azure environment. As you can see, we have like the front door that I already explained. So let's maybe have a quick look to what the front door is doing. So this is my front door, which is the reverse proxy. So you have an endpoint name. You have a security policy that is being applied. Here you see the web application firewall. And here you also have my actual app service, which is running. So just to give you an idea, so this URL, it's actually this site, and it's just the most secure web page because it's being protected by a web application firewall. So it's just like a web form, nothing too fancy, but it can be a full-blown application behind that front door, of course. So this is, voila. So thanks, it's just submitting a form and that's it. So that's really like the front door. Now, if we go and have a look at our firewall policy, let's have a look at the web application firewall policy. So here you see that we have policy settings, we have managed rules, and we have custom rules. So the managed rules, and that's what I wanted to mention here as well, they are really, as you can see, based on remote command execution, PHP injection. So based on signatures, based on certain things that you are going to do. So for example, this is like cross-site scripting. Now, this of course doesn't work because I'm not embedding JavaScript in my my parameters, but this is just a signature that of course every firewall should recognize. But if you do script alert, then it's going to say, okay, your request is blocked. So I know my web application firewall is working. How do I know that? Well, if you go to your policy settings, then you will see this is the page. You can create a customized page, of course, but it's a demo. So here we made it pretty straightforward. So you have your managed rules, but then you have something also interesting is a custom rule. So here I have block bad IPs, and I already tested certain things. So I'm going to delete them now because otherwise you will see that it's not being added. So let's save this one. Save. So now we have like one IP that's by default, it's blocked. It doesn't have any connections anymore to our backend. So we are offloading our backend here. Now, from a logging perspective, what do I want to know? I want to know, okay, what do I see within Frontor? And you can easily go within Frontor towards monitoring and logs. And there you have, for example, the Azure diagnostic log. And if we now say, okay, run, let's maybe run it for the last, okay, it was a pretty easy one. So here you see, for example, a lot of logs are being written. And it are interesting logs because here I have web application firewall log and I have Frontor access log. So you see that my web application firewall is generating logs, but also just generic access log is generating entries. So let's have a look here. What is in the log? What is pretty interesting information? Well, you see, you get a 403. We actually see, okay, that's being routed. We have a client IP. So the client IP is over here. If I'm not mistaken, it should be in here. Yeah, client IP is in here. So there's also a socket IP. So that's already interesting information. And also you have the request URI. And here you see it. This is coming from the Frontor access log, but then it's additionally logged as the web application firewall. But you see here certain patterns that are not really good. If you then go to your Frontor web application firewall, you will see that the same IP address, so the same client IP, actually has a block, and you have an anomaly score, why it was being blocked. And there you see then, the anomaly score, and you also see the signature there. So a lot of information in here, always good from an engineering perspective to have a look and together with your product captains to see, okay, what kind of information is in there, because we are going to leverage that one. So here, this is the security portal, so Microsoft XDR. I don't know if a lot of you are already using it, but this is Microsoft XDR, and nowadays Sentinel is integrated within that portal. So you have here the Microsoft Sentinel. So here all the logs are being concatenated, and actually, let me quickly have a look at that one. So if you go to diagnostic settings, you will see that I am, there are the demo gods, bandwidth. So here you see that we are forwarding them towards a log analytic workspace. So again, the structured database table. With Sentinel, we are monitoring that table, and you can also do it here in advanced hunting. So typically when I start like a new automation that I want to test out, I will do it within my hunting, and I will actually start with advanced hunting and see, okay, what can I find related to Azure Diagnostics? We run the query from in here, and again, same results. You see it here, it are just the same results that are now being centrally stored. So let's have a look. I already prepared like a query. Let's have a look like, okay, what can we see? So this query, this is KQL. So it's like the query language of, Log Analytic Workspaces and Microsoft Azure as well. So what is it going to do? Just very easy. It's going to filter on those logs. What was happening within 6 hours, where Frontor access log, and then we are going to just count all the rows by client IP. So if we run that query, there's no tabular expression found. So there are the demo gods again. Let me quickly. Online one. Yeah, okay. Problem is, you cannot define a query in a variable if you're just going to execute that query. So run that query, all live performed. And you see here, my IP address, you see another IP address, coming in with total requests. So that's already good. We now know, okay, there's traffic, and we see a lot of requests coming from that, which already could be an indication that scanning is going on. So from that perspective, I will now have a full paste of that query, just so you can see how I developed this one together, of course, with, and I have to thank our Microsoft detection engineers as well, because they did an awesome job doing this in production. So just to explain access logs, here you have the summary, the total requests. From the blocked ones, we also want to have a summary. And then, of course, we want to combine them. So here we are going to combine them based on client IP. And you are actually going to see which, let me quickly delete this one because this is already for our detection rule. But we are going to see per IP how many requests were blocked, what is the total, and what is the calculated percentage. So if I now run that query on my data, you should see the same IP addresses. Yes, and you see here that amount of blocked requests, that amount of blocked requests. So based on the total amount of blocked versus total, we already have a pretty good indication that even 30% of that traffic is actually potentially malicious related towards a scanning tool. So what can we do now with this? Well, we can create a detection rule, and that's pretty easy to do. So within Sentinel, you have analytic rules. I already created this one, so which is called high volume of blocked requests. So, but pretty straightforward to set up. Let me quickly go through the GUI. Here you just give it a name, you give it a description, severity, reconnaissance, the MITRE attack techniques, but the rule logic added the important one. So again, pretty useful feature, view query results. So you can immediately see, okay, what are my results here? And here you see total by IP. Again, it's exactly the same query, but we only now, and that of course needs some fine tuning, perhaps within your environment, but here, and we can actually update it continuously, depending on how much attack scenarios we want to cover. But here we put it on 60%. And also maybe an important aspect as well, with entity mapping, you can map it towards standardized objects in your incident. So custom details, you can also add custom details, which you can then also read out within your automation playbook. So, and then a little bit of details there on why and how to run it. So let's see, because that rule was already active, let's see if it generated an alert. And indeed, it generated an alert here, high volume of blocked requests. And within this one, you see that we have two alerts. You see in the evidence and response, an IP address. So that's something we can work with. So very basically, this is a custom rule that generates an incident based on alerts. This is the query that we are executing on a regular basis based on those logs. So within that evidence and response, we can now actually execute, and you can do it over here, run playbook, or you can even do it automatically with the automated response, which you can find over Sentinel automation, which you can find over here. So here you can create, like, if that incident occurs, always execute that playbook. Now, the most important part there is our playbook. So let's have a look at the playbook and how we developed it. So add IP to watchlist incident trigger. So this is the playbook. Here you see that it succeeded to run. You also see that it failed. Good to know if you are going to develop and troubleshoot your playbook. Well, here, for example, you can then see which step or which action was failing. And then also, typically, this is the API call. And here you see that there's a reason. The reason why it failed is because we got an internal server error. So that means within our input, and this is the full input of our data object, so JSON, we see something is wrong there, but the last runs were successful, so we fixed that one. Now let's have a look at how or what we are doing in this one. So we have the Microsoft Sentinel incident, which is of course our trigger. And let me also go here into this one so that we can already start our automated playbook. So if I click here, run playbook, then I can say, okay, I want to block this IP address. So run playbook, and then you're going to block that IP address. So now that playbook is running, if I go back here, you will see there's one running. So everybody's got the hang of this. So it can be quite overwhelming, but this is just like the history of the playbooks. So let's go a little bit into how I developed together with our engineers this playbook. So you have the Sentinel incident. So an incident is coming in. What are we doing then? Well, we have the IPs because it's an entity. So we get those IPs. We are going to add those IPs. And so a lot of automation is also parsing data, put it in the correct format, checking the data. So we are going to parse that data and we are going to add it towards a watch list. Now, if that watch list is not available, then here you will see it's going to create that watch list and it's going to import it as a CSV table. Or if it's already there, then we are actually going to execute our other part. So we're going to, maybe an interesting one, we are going to validate that one, and I will reject that API key in a little bit. But we're going to validate it with abuse IPDB, but you can do a lot of other API calls related to validation. This is just a small example. And if it is a malicious IP, then you can even do further investigations, or you can immediately block it and add it towards an overall block list. So we are going to add that IP to the watch list, and then here, that's a pretty interesting one. So here we need, and that's how Azure and actually the integration with the Azure API works. We are going to integrate it with our web application policy. So here you're going to get the full details of your web application policy. And as I already mentioned, you have the managed rules and you have the custom rules. You are going to parse them here. What is a great feature? Use a sample payload, and you can actually use that sample payload to generate your scheme, and then you have all those variables available. For each rule, what are we going to do? Well, we are going to parse that rule, and then if that custom rule exists, then we are going to create a new object, which is, in this case, a new JSON object. So it's going to be a new firewall policy where we are going to, and this is the new IP list here, where we are going to add those new IPs. So this is really like a lot of information, a lot of values, a lot of JSON information, but then you are going to append it, and then you are going to do a put request with my new custom rule. And if everything went well, let's hope everything went well, then we now should have a succeeded one. Yes, we have. And you can entirely follow that flow. Let's quickly have a look if it was able to add our new update policy. So again, this is JSON. You don't need to fully understand it. But here you will see that's my IP address that I actually executed those attacks with. And is that now being added towards our web application firewall policy? Remember, I deleted all those IPs entries in the previous part. So let's hope that it's now in there. Block bad IPs. And yes, you see it's in there. So wow, we automatically blocked, after a couple of minutes, we automatically blocked like an IP that was still able to connect towards our application. Just to give you an idea, how long did it take? Well, it took 1.46 minutes. You also have the detection rule set, so you need to, there's a certain delay there. So hopefully this was interesting and insightful, and you have some ideas related to how to automate, or what automation can do and how it can help you. Now, very rapidly, because we're almost out of time here. So conclusion, I think where prevention fails, there we can use detection and automated response. Environment, know your environment. So fine tune it, define also a clear scenario that you want to automate so that you know what is my outcome there. And automation, as you already saw, saves time. So we were able to actually block this IP address within a couple of minutes. So normally also now, if I go to this one and it's not being catched, by default, look, there's no attack anymore. So by default, I'm blocked. Use enrichment playbook. So start maybe with enrichment, because enrichment and data is very valuable for our security analysts. And again, start with a minimum valuable product so that you can improve over the long run.
Proximus next? Think possible.